Welcome back for lesson. We're still in section 5.1, talking about rational expressions and rational functions. We just talked about the domain of a rational function, and now we're going to learn how to simplify rational functions that are a little bit bigger than the ones we did at the beginning of lesson 5.1 in the A video. So let's look 21, 23, and 25 are where we're going to start. And these are getting a little bit bigger, so take a deep breath, and here we go. Hopefully you're going to build some skills in factoring while we're at it. Okay, 21, we are jumping right in. To simplify this, we can see that this is two terms. It's a to the fourth minus 81. And because it's two terms, it could only be a difference of squares, a difference of cubes, because it's a subtraction. It's not a cube. And it doesn't look like it's a square, but it really is. This is really a squared squared minus 9 squared. And then a minus 3 in the denominator is already simplified. We can't factor that at all because it's an a to the 1. So that's good. That part is kind of done. But we do have a difference of squares on top. So this is really a squared minus 9 times a squared plus 9 over the a minus 3. Now, this is a great one for the factoring flow chart when we go, oh, are we done? Well, because there's a square in both of these, we still have to ask ourselves, are we finished? So the a squared minus 9 is two terms. So it could still be a difference of squares. And it is, this is really a squared minus 3 squared. So this is another difference of squares. And that's an a minus 3 times a plus 3. And those are done because they're a to the 1. Okay. Now the a squared plus 9 has two terms, but because it's a plus, we never can factor a sum of two squares. So that one is all done. It cannot factor anymore. And then we have the a minus 3 on bottom. And now we actually get to simplify. And because we have an a minus 3 on top and an a minus 3 on bottom, they make a 1 for 1. They crash and go away. And so we are left with only a plus 3 times a squared plus 9. And again, a plus 3 cannot be factored anymore because it's an a to the 1. A squared plus 9 cannot be factored anymore because it is a sum of two squares, and that is not one of our options for two terms on the factoring flow chart. Whew, that was a big one to get us started. So 23, let's see if we can factor these. So again, we have, let's see what we have in common to factor out between 20 and 45. So they both share a factor of 5. So we have 5 times 4y squared minus 9. And can we factor? Let's just finish the numerator. So now on top we have 5 times 2y squared, right? Minus 3 squared. So it is a difference of squares. So we can write the numerator as 5 times 2y minus 3 times 2y plus 3. That was another difference of squares. And the denominator, we could factor out of 5, and then we have 2y squared minus y minus 3. So when we factor out of 5, each of the terms has to be divisible by 5. And if you were to distribute the 5 back in, you would have to get back to the original, which it does. So right off the bat, our 5 over 5 cancels, so that's nice. Now I'm trying to factor. I'm going to use some guess and check here on this 2y. So that's going to be 2y times y is 2y squared. And I need to make a 3, a negative 3, which is a negative 1 and a 3 and a 1 and a negative 3, but they add to make a 2 and a negative 2. So let's do the 3 here and a 1 here, because this will make a 3y and this will make a 2y, and we need a difference of a negative 1 in the middle. So we don't need to worry about that. So we've got 3y and 2y, and we need it to be negative in the middle, so this has to be the further negative. So this will be the negative 3 and a positive 1. So this is 2y minus 3 times y plus 1. So you're getting some really good factoring practice here too. So the 2y minus 3's cancel out, and we already canceled out the 5. And so we're left with 2y plus 3 over y plus 1 as our final answer. Okay, the next one, let's factor out what we can from top and bottom. So it looks like the top shares a 2 and a y in each term. So let's factor out 2y. And then we have 6 minus x left. Minus x squared. Okay. And on bottom, we can factor out a 2 and a y as well. So that's awesome. And we have a 3 left minus 2x minus x squared. Okay, so right off the bat, our 2y over 2y cancels, so that's fabulous. Now it looks like we have 3 terms in the numerator and denominator. The weird feeling is that this x squared is at the end. It feels kind of weird, but we're gonna manage it. So the only thing with the 3 terms is that we could possibly factor it into 2 binomials. They're both going to be this situation. And so it's going to be kind of some guess and check. So I have to make 2 numbers that multiply to make 6. So I'm just going to make my list over here to make 6. I've got 2 and 3. And they multiply to make a positive 6, but okay, so in a negative 2 and a negative 3. Okay. So right now they add to make a positive 5 and a negative 5, but because we have this negative x out here, it's going to force one of these to be opposite signs. So that will be good. So when we add them, we'll get a difference of 1. So let's just do 2 and 3. And then we're going to have x and x to make the x squared. One of the x's needs to be negative because it's a negative x squared. And we're going to do the one on this x. So when it multiplies here, the negative x times 3, we get a negative 3x to make the difference of a negative 1. So this is a positive. And I'm going to show you how that works. So if we were to multiply these, we would get 2 times 3 is 6. I'm going to write that down here. And then 2 times x is a positive 2x. And then underneath we would get a negative 3x. And then a negative x times x is a negative x squared. And then that's what causes the middle terms in the middle. So we get 6 minus x squared. So that's how that works. Okay. Now the numerator is going to be something similar, and ideally the denominator will be something similar, and ideally it will factor into something that's in common with the numerator, so that helps us out there. So 3 can only be factored into 3 times 1, and then we've got our x and x again, and we need a negative 2y in the middle, so we need the 3 to become negative, so that's going to be a negative over here and a positive. And it looks like we have a 3 plus x in the numerator and denominator. So those will cancel because they make a 1 fraction. And our final answer is the 2 minus x in the numerator and the 1 minus x in the denominator. Woo, you're getting some good challenge here. Okay. To number 29. We'll do a few more and then we're going to break this up into another video. So 29, 29. To factor these, we've got 2 terms. So this is going to be and it's a sum and it's cubed. So this is the sum of 2 cubes. And we need to go back to our factoring flow chart so that we can make sure that we are factoring this correctly. You should have your factoring flow chart out in front of you, and so should I. Right there it is. So that we've got our breakdown for those. So our sum of 2 cubes is over on the left here. And right there is our formula. A plus b times a squared minus ab plus b squared will be the sum of 2 cubes. So so ours is going to be x plus 1 is my a plus b. And then we're going to have x squared minus x times 1. And it could just be left as x plus 1 squared. And that simplifies to 1. So that's x plus 1, x squared minus x plus 1. Now those cannot be factored anymore because that is the rule of difference of cubes, unless what your a and b, your x, if x was actually an x squared or an x to the 4th or something, it could maybe still be factored a little bit more. But this one stops here at the x plus 1. So we know they're both done being factored. Now the bottom is a difference of squares. So that's an x plus 1 times x minus 1. And we can just fill that in here, and we can see that those are going to cancel the x plus 1s. So our final answer is x squared minus x plus 1 over x minus 1. Let's look at 32. So 32, we're going to factor out what we have in common. So we have a times d. And when we factor that out, we just have a 1 left over because it needs to have a place value, and then minus a d. And then we have d minus 1 in the denominator. Okay, when we have this situation, we can see that 1 minus d and d minus 1, they feel like they're the same, but they're not really the same. So let's just write it like this, a times d, and let's just put the d first, just so we can see that they're not quite the same when we put the d's first, but they're opposite signs. So let's go ahead and factor out a -1 also from the numerator in this minus d plus 1. So we have a negative a times d. And when we do that, that makes our d positive and our 1 a negative. And then now we have the same of the d minus 1 over the d minus 1. And that leaves us with a negative AD for number 32. Now, number 33 is fun. That's a new one because it's 4 terms. So we have our grouping, factor by grouping. And so let's group those. Let's look at our first two terms. Our first two terms have an A in common. So when I factor those out, I have a B minus 1. And then the second two terms only have a 1 in common. So let's just acknowledge that it is a 1. And we also have a B minus 1 left over. So now we can pull out what's in common between this group and this group. And what is in common here is the B minus 1. So we have a B minus 1 times an A plus 1. Okay, now in the denominator, we have the grouping again. So I'm going to group them like this. And so again, we have an A in common, and then we have a B plus 1 left over. And then B plus 1 only has a 1 in common again. And we have a B plus 1 left over. Now looking at the big picture of what these two groups have in common is a B plus 1 and an A plus 1. So the A plus 1s are in common. And we have a B minus 1 over a B plus 1. Let's look at 37 and then we're going to take a break and we'll make video part C, A, B, and C. So number 37, 8, 6, and 9 do not have any common factors between all three. So we are looking for some guess and check here on the 8 times the 69, because it's really, we're looking for factors of 8 times negative 9. So it's a negative 72. And we need them to add to be a negative 6. So you can go to, let's go to Desmos. Let's see how we could use Desmos in our favor here. So Desmos in our favor. So let's look at factors of a negative 72. So let's just look at y. Let's say we want y to equal a negative 72 divided by x, because that's another way of saying x times y makes a negative 72. Now don't look at the graph. We don't really care about the graph, but we do care about the table. So we can see that and let's do x plus y. You won't let us do that. We can do that one in a minute. So we want to see, we want y to equal, we want y plus x, right? We want y plus x to equal a negative 6. Okay, so we want y plus x to equal a negative 6. Let's see where these so when we add them together, they get a negative 6. So if we solve for this, y will equal a negative 6 minus x. So let's do that. Y equals a negative 6 minus x. A negative x minus 6. Okay, there we go. So we want this to be, we're looking for the same numbers. So I'm going to just see what other numbers divide into 72. So 6 does, a negative 6 does, 12. We see 12 does, 9 does, 8 does. Okay. So we need both equations, red and green here, to match. And so that looks like here at the 12, the negative 12. So 6 and negative 12 are going to be our pairs that can help us. Now you can be doing guess and check if you want. So 6 and negative 12. So let's go back to our paper here. So 6 and negative 12 can help us. So we can rewrite this as 8x squared plus 6x minus 12x, because that's our grouping method, minus 9. And now we can do the grouping method. So we're basically making this middle term into the grouping method with factors of a times c. So with the grouping method, we have, where's this? Let's write it out with the grouping method. Okay, so if we factor out what's in common, 2x, and then we have 4x plus 3. And then what's in common here is a negative. Okay, that stays grouped together. And then what's in common here is a negative 3. And then what is left over is a 4x plus 3 as well. Now remember, with the grouping method, you want them to have something in common, and they do, the 4x plus 3. Awesome. So that means the 4x plus 3 is one binomial, and then we have 2x minus 3 left over. Okay, so we're going to do something similar here with the 8x and the minus 18. This time we need them to be, the middle numbers, right? X plus y to equal a negative 18. My two numbers that multiplied to make 72. So y is going to be a negative x minus 18. So let's type that into Desmos. We're going to change that here. So instead of minus x minus 6, we're going to do minus x minus 18. And it happens to be their 8 and 9 are 72 again. So this equation works. So we want them to be the same. We're looking for where they're the same, not 12 and negative 12, but we need them to be exactly the same. Oh, instead of negative 72, we need to be positive 72. That will change things. So let's just see here. Where are they the same? So we also have to try a negative 9, and negative 8, negative 12. Oh, negative 12, there it is. Negative 12 is negative 6 and negative 6. Okay, so we're using negative 12 and negative 6. Negative 12 and negative 6. Okay. So let's go back to my paper and we're going to figure it out. So we can do for a grouping here, we know that this is 8x squared minus 12x minus 6x plus 9. So now we're going to factor what's in common here between 8x squared and 12x. So that would be, oh, and look at, you can see the signs are opposite. It's a positive 8, a minus 12, a minus 6, and a positive 9. So one of them we're going to have to factor out a negative. So let's factor that out here. So let's factor out a negative 4x. And when we do that, we have a negative 2x left plus a negative 2x plus 6. No, a negative 2x plus 3. Plus 3. Okay. And then from this group, minus 6x plus 9, we have just as is, we have a 3. So we're going to pull out a positive 3. So we have a minus 2x plus 3 left as well. So that's what's in common, is the minus 2x plus 3. So minus 2x plus 3. So a minus 2x plus 3. And then we have a minus 4x plus 3. Okay, and now look at, we ended up with 4x plus 3 on top and a minus 4x plus 3 on bottom. So those are not going to cancel. No. Oh, wait, that should be a negative 4 comes out and it's a positive. So it's going to be positive. That's going to be negative. That's a negative. Okay. But the 2x minus 3 and the minus 2x plus 3, we can factor out a negative 1 from the denominator here, and that will turn that into 2x minus 3. So we'll have 4x plus 3 on top times 2x minus 3 over a negative 1. And when we do that, we get a 2x minus 3. And then we still have this negative 4x plus 3. Okay, and so those cancel. And we're left with a 4x plus 3 in the numerator. And then you could multiply these through. This would be a negative 1 times this negative 4x. So it'll be 4x minus 3. That was a tricky one. So let's take a break and catch me back for part C. We're going to start with problem number 41.